So we're in this last section, 4.8, and this is this long division. So what I'm going to do, I'm just going to go over some more examples, and there's some variations of this. And there's a particular example that we want to be aware of, because this is something that can come up. Now let me see here. Okay. So just to review what we looked at last time. Here, let me find a pen.
Yeah, before you came on, I was actually going over, like going through like kind of the notes from last time. And then I was just wondering like about like the standard, because first we have to make sure that it's in standard form, right? Because I wrote that down.
Correct.
And then
So
what do you
if
mean? What do you mean by standard form? Like, is it like, you know, like the divisor and then the box and then the what and then the numbers inside? Is that basically what standard?
Well, if you have something like this, what you want to do is you want to take these polynomials and reorder them so the terms with the highest degree are first, and terms with the lowest degree are going to be last. So in this case,
so by terms and degree, you mean like 9 being the term and then A being the degree?
Well, each of these are going to be terms, and terms are going to be separated by a plus or a minus sign. And the degree you get from the exponents. Okay. Now, constants, if you don't have a variable attached, that's going to have a degree of 0. And that's just always, and that's why this 4 and the 20 have a degree of 0. Now, for a variable like a or 9a, they're going to have an invisible 1, right, also as an exponent.
Right. Okay. Yeah. Yep.
So that's why this is a degree of 1. This entire term that has the 9 attached to it, it's still only a degree of 1. And that's because we're only looking at the exponent.
Right.
Now this one, because it has an exponent of 2, it has a degree of 2. Now what this means is when we put this in standard form, highest degree term is going to be first. Then the next highest, then the next highest.
So highest to lowest.
Exactly. And that's going to be your answer. Well, not the answer.
I was going to say not the answer, but how we set it up.
Correct. But you want to set it up like this first, from highest degree to lowest degree, highest degree to lowest degree.
Okay.
All right. So then once we've got that, then we're going to do the division. And we're going to set the division up like it's regular long division. Now, what we do is the term that's going to be doing the work is going to be the first term of the divisor. We have the divisor and the dividend. And the first term of the divisor, this is going to be doing all the work. And we're going to go first term by first term. So we'll take first a squared divided by a. And that's just going to give us a. so that we'll put here. You can kind of think of this as the a squared column, the a column, and the constant column.
Okay.
Then we're going to take the same a and we'll multiply it to this entire thing. And we're going to distribute. We'll get a squared plus 4a. And we put that back into our division. Then we're going to subtract a squared minus a squared is 0. 9a minus 4a is 5a. And then we bring down this next term. And that's our first cycle of division. And so now we're going to start the process over again. So any questions so far?
No, not as of yet.
Okay, we'll be doing this a bunch of times. It's just one of these things where I think it just takes practice. So now we're going to start again, except instead of working with this and the first term of this, we're now going to work with this and the first term here. So take 5a divided by a. We're going to get 5. Now that's a constant, so we'll go plus 5, sort of in this constants column. Let me make that look a little more like a 5. And now we're going to take 5 and multiply it to this entire thing. Oh, change my pen here. We'll still get 5a plus 20. And then we're going to subtract again. And again, we're going to get 5a minus 5a, 20 minus 20. Well, that's all going to be 0. And if we look up here, there aren't any more terms to bring down. So we're done. So the answer is going to be a plus 5. Now, what this is actually saying is that if we took a plus 4 and we multiplied it to a plus 5, we're going to get a squared plus 9a plus 20.
Okay, so it's the reverse.
That would be the reverse. But that's it. But your answer would be a plus 5. Questions about that?
No.
Now let me. Oh yeah. But let me show you one a little more complicated.
Okay.
Let's say we have this. Maybe not complicated, but it's going to have a slightly different type of result. So first off, we want to check for standard form. Highest degree to lowest degree. Highest degree to lowest degree. So we're good. We've got it in standard form. Now we're going to put it in long division form. And we're going to do the exact same thing. That's going to be doing all the work. And then we work with these first terms to start out. X squared divided by x, and that's going to give us just x. So that x is what goes up there. Then we're going to take that x, multiply to the entire divisor, and we'll distribute it. We'll get x squared minus 2x. And so now we're going to subtract. Now for the x squareds, again, it's x squared minus x squared. Now that's going to be 0. But for this one, x minus a negative 2x, you're actually getting something like this. X minus negative 2x. Well, that's going to be a double negative. So that'll be x plus 2x, or 3x. So you want to be careful with some of these. They can be a little tricky. Like often what people will do is they'll see the x and this minus sign and say, oh, that's 1x minus 2x. That's going to be negative 1x. But actually what's going on, it's this minus this entire object with a minus sign attached to it.
Okay.
So this minus a negative 2x. And that's why you're getting that double negative. So that'll come up from time to time. So we'll bring down the +1. And then that's it. That's our first cycle of division. So any questions so far?
No.
Oh. So now what we're going to do, we're going to repeat the entire process, except instead of using this, we're going to use this. So this first term divides into that first term. So this 3 will multiply the divisor. Yeah, 3x minus 6. And again, we're going to subtract. So 3x minus 3x, that's going to be 0. But here you have a 1 minus a negative. You want to kind of keep an eye on that. You have 1 minus a negative 6. That's going to be 1 plus 6 because that double negative, or 7. So you're going to get 7. Now, we don't have any other numbers to bring down. There's no other terms to bring down. That was the last one. But we actually have a remainder now. It didn't come out to be 0. So for our answer, it's not going to be just x plus 3. The answer will be x plus 3 plus the remainder divided by the divisor. And this is something that comes up in long division. Like if you have in long division 5 with a remainder of 2, and let's say you were dividing 5 into 27. So like if you did something like this, 27 divided by 5, your answer would be 5 remainder 2. And this is the divisor. So the way we write this, another way of writing is 5 plus 2 over the divisor 5. That's the other way of putting this. So we're going to do the same thing with polynomials. You could answer and say this is x plus 3 remainder 7. That's perfectly fine. But you could also say, we can put it in this other form, it's x plus 3 plus the remainder divided by the divisor.
Okay.
So any questions about that?
No, no. I do have one about the homework though. Just whenever we get it, like towards the end maybe of the class, I just need to figure it why.
Absolutely. Well, absolutely. Let me show you a couple more. There's some that there's a special form that there's a, like we mentioned standard form, and there's a situation where you can actually be missing terms. And that's something that we're going to take a look at.
Okay.
There will be a type of problem where you're going to have to insert extra terms. So here are the problems given in a fractional form. And all we're going to do is convert it first into long division. Now it's already in standard form, highest degree to lowest degree, highest degree to lowest degree. So we've got that. So let's put it in long division form. Now for this one, again, we're going to have 3x doing all the work. we have 15x squared so this time, if we divide 15x squared by 3x, we get 5x.
And we don't put that over the 15. We put it over the next term coming up.
Correct.
You know what I mean?
Correct. What it is that this is a type X and this is a type X. They have the same degree of 1.
Okay.
So I'm sort of treating it like this is an X squared column, and this is an X column, and this is a constant column.
Gotcha.
So that's the rationale behind it. Then we're going to do the same thing as before. We'll distribute that 5x. And what we'll get will be 15x squared plus 40x. Now,
And
again,
just like in long division, Mr. Coburn, we always subtract, right?
correct.
Okay.
You're always going to subtract. Now, there's a shortcut procedure they'll teach in Math 107 called synthetic division, but that's a whole other story. I mean, you change things a little bit, but just like with long division, we're always going to subtract. Now we have 15x squared minus 15x squared. Again, that's going to be 0. Here we have 19x minus, don't want to forget the minus over here, minus 40x. So basically you could think 19 minus 40. Well, that's going to be a negative number. We get negative 21x. Bring down the minus 4. And then we finished our first cycle of division. And then we could just repeat the process. So we'll take the first term here, divide by this first term, we'll get negative 7. And so that minus 7 goes over the constant. Constant over constant. Then we'll take the negative 7. We'll multiply that to the entire divisor. So distribute that negative 7. Negative 21x minus 56. 7 times 8 is going to be 56. So you get negative 21x minus 56. And then we're going to subtract. Well, once again, negative 21x subtract itself. anything subtract itself is going to be 0. So we're going to get 0 here. But we want to be careful with this next one. -4 minus a -56. That's -4 minus a -56. Well, got a double negative, so it becomes -4 plus 56. That's going to come out to positive 52. And then that's it. That's our second cycle. There's nothing else to bring down. No other terms we can bring down. So we're done. We just have to figure out how to give the answer. So again, the answer, you could say it's 5x minus 7, remainder 52. That's fine. But the way they're going to want you to write it is in that divisor form, where it would be 5x minus 7 plus 52 over the divisor, 3x plus 8. Questions about that?
No.
So let me throw another one out. Let's see here. Okay. So let's say we have this. So if we have something like this, again, we want to check for standard form. So highest degree, this is a degree 3. To lowest degree, this is a degree 0. Highest degree, it's a degree 1. Again, that's going to be degree 0. Well, it's in standard form. And again, we want to order this from left to right, from highest degree to lowest degree. And okay, so far so good. So let's put it in, well, before we put it in long division form, you might notice we're missing, like this one's a degree 1 and a degree 0. Here we have a degree 3, we're missing degree 2, we're missing degree 1, but we do have degree 0. So we want to fill in missing terms. We want each degree, if you have the highest degree term, lowest degree term, we want terms that represent the degrees in between. Now this is degree 1 and degree 0. There's no whole numbers between 1 and 0, so this is complete. This is fine. This one's missing a degree 2 and it's missing a degree 1. So we want to make sure those in-between terms with those in-between degrees, I want to make sure those are there. So the way we do that is we put in a 0 x squared. And again, 0 times anything is going to be 0. We put in a 0x minus 1. And then we have x minus 1. So now we have all the degrees, the whole number of degrees represented. Degree 3, degree 2, degree 1, degree 0. Degree 1, degree 0, all good. So any questions about that before we do and launch into the division?
And it's always a 0? before?
It's always going to be a 0. And the reason it's 0, because 0 just cancels things out. So if you cancel this and cancel this, as we usually would, we're going to get the original x cubed minus 1. So technically, we actually haven't changed anything. It just looks different. So let's jump into that division. So now we have this. So again, the first term of the divisor, it's going to be doing all the work. And we'll take first term divided by first term. So x cubed divided by x is x squared. So here we can kind of think of it again like columns. An x cubed column, an x squared, an x to the 1, a 0 degree column, or a constant column. So since we got an answer of x squared, we'll put it in the degree 2 column. Then we take that x squared, we multiply it to the x minus 1. And if we distribute this, we'll get x cubed minus x squared. Now again, we're going to subtract. X cubed minus x cubed is going to be 0. And then you have 0x squared minus a negative x squared. So again, we've got that double negative thing going on. So this becomes 0 plus x squared, or just x squared. Bring down the next term, and then that's the end of our first cycle of division. So any questions?
No.
All right. So now we're going to repeat the same process. X will go into x squared. And that gives you x. Now again, we'll take this x, multiply it to the divisor, and if we distribute, we'll get x squared minus x. And if we take a look at this, x squared minus x squared, well, that's going to be 0. And again, we've got a 0 minus a negative. Well, negative minus negative is positive. You get 0 plus x, or just x. And then we bring down the last term. And that's the end of our second cycle. And so this one's going to go 3 cycles instead of 2. And we have 1 cycle left, that third cycle. So again, first terms, first terms. So it's a positive 1, so we'll call the plus 1. Then we multiply that. X minus 1. And, anything times 1 is just going to be itself, but you could distribute the 1 anyway, but either way, you're going to get x minus 1. And now we subtract x, subtract itself, 0, minus 1, subtract itself. It's also going to be 0. And then that's it. We're done. Nothing else to bring down, so that's the end of our third and final cycle. No remainder this time. So the answer will be x squared plus x plus 1. Questions about that?
No.
Now, sometimes the missing term can be a little subtle. So you might see something like this. Okay, I'll take the parenthesis, I'll remove that. So you would look at this and you might say, okay, this looks fine. I don't see if there's any issue here, but you want to be careful. Degree 1, degree 0. All right, we have consecutive degrees. Degree 3, degree 2, degree 0. We're missing degree 1. So we need to make sure there's a degree 1 in there. So we'll put in just a 0x, and that's going to give us that degree 1. And so now the whole thing is complete. Degree 3, degree 2, degree 1, degree 0. And then we go ahead with the long division. So any questions about that?
No.
So I'm just going to go ahead. I'll do the long division here. And again, it's just one of those things that takes practice. You just see it a million times. You're like, oh, okay, I'm getting the hang of this. Oh, that's an x cubed. And again, the first term of the divisor, that's going to do all the work. And then first term, first term. So x cubed over x is x squared. So put that over the 4x squared, the degree 2 terms. X squared times x plus 2 . And again, we'll distribute the x squared. And then we subtract x cubed minus x cubed, that's going to be 0. Excuse me. 4x squared minus 2x squared, 2x squared. Then bring down the next term, plus 0x. Excuse me. And you notice each time we're bringing the operator with it. The operator goes with the term. And then that's it. That's the end of our first cycle. So now we do the second cycle. 2x squared divided by x. Well, that'll come out to 2x. So we put a positive 2x in the x column. And we take that 2x, multiply by the divisor, and so this gets distributed. That gives us 2x squared plus 4x. And then we subtract. 2x squared minus 2x squared is 0. 0 subtract 4. That's going to be negative. Negative 4x. And bring down that minus 8. And that's our that's the end of the second cycle of division. Well, next we're going to take minus 4x divided by x, and that's going to be equal to minus 4. So you have a minus 4. Then minus 4 times x plus 2. We'll get minus 4x minus 8. And then if we subtract these, well, minus 4x subtract minus 4x, that's just minus 4x subtracting itself. That's going to be 0. You have minus 8 subtract minus 8. And again, minus 8 subtracting itself, that's 0. So we're done. That's it. So that means the answer is x squared plus 2x minus 4. Questions about that?
No.
So there's really one more I want to show you, and that's pretty much it. Let's take a look at that one from the homework. So let's say we have something like this. Now, again, we want to check to make sure everything's in standard form. So we want it in decreasing order from highest degree to lowest degree. So degree 4, degree 3, degree 2, degree 1, that invisible 1 on the single x, degree 0. Then degree 2, degree 1, degree 0. So far, so good. It's all right. It's in standard form for both the dividend, which is on top, and the divisor, which is on the bottom. So let's put it in long division form. So same procedure as before. The first term of the divisor is going to be doing all the work, or a good share of it. And we're going to divide by first terms. So x to the 4th over x squared. Well, that's going to be x squared. So we put this in the degree 2 column, so to speak. And then we take the x squared, we multiply to the entire divisor. We get x to the 4th minus 3x cubed plus x squared. So now we do our subtractions. So you have x to the 4th minus x to the 4th. Again, that's going to be 0. Now, this one, take a look at the x cubes. We're going to have minus x cubed minus negative 3x cubed. So you want to be careful with this one. Negative x cubed, because it takes the operator with it, minus negative 3x cubed. Well, that's going to be negative x cubed plus 3x cubed. And negative x cubed plus 3x cubed, that's going to be 2x cubed. And then we've got one more subtraction. Negative 4x squared minus x squared. So if you're not sure, you can always do this off to the side. Minus 4x squared minus x squared. Well, negative 4 subtract 1. And so that gives you negative 5x squared. It's like it's negative 4 degrees. It got a degree colder. Now it's going to be minus 5 degrees. Then we bring down this next term. And that's the first cycle of division. Questions about that?
No.
So now again, we work with first terms. And that's going to be 2x. So it's a positive 2x. So you go plus 2x in the sort of the x column here. And we take 2x. X squared minus 3x plus 1. Distribute that 2x. We'll have 2x cubed minus 6x squared plus 2x. And again, we subtract 2x cubed minus 2x cubed, and that's going to be 0. Again, this one, you're going to get kind of a funky one. Minus 5x squared minus negative 6x squared. So I'll be minus 5x squared plus 6x squared. And that's going to be x squared. And so now we got to do the subtraction for the x's. So we have negative x minus 2x, positive 2x. So it's like negative 1 subtract 2, or if it's negative 1 degrees, it gets 2 degrees colder, you get negative 3x. Bring down the plus 1, and then that's it for the second cycle of division. Any questions about that?
No, not yet.
So this is going to be the last cycle. First term, first term. So it goes in 1 plus 1 in the constant column. Then we have 1 times the x squared minus 3x plus 1. And when we multiply 1, we just doesn't change anything. So we're just going to get x squared minus 3x plus 1. And then we do our subtractions. It's just going to be the same term subtracting itself. This term subtracting itself. This term subtracting itself. That's just going to be 0. And that's it. That's the end of the third cycle. So this will become x squared plus 2x plus 1. And that's going to be it. Those are really the different types of problems you're going to encounter in section 4.8. Now, what I'm going to do, what this does is lets us finish essentially a day early. So I need to come up with an activity for, we have our test. I apologize. We do have our test coming up. So we do have the chapter 4 test. Okay, we're not finishing a day early. We're finishing on time. But other than that, any questions?
No, not really.
So that's it for the lecture. If you have any homework questions, let me know. And other than that, that's going to be it.
Well, I actually